Okay, so what I got here is an LED attached to a battery and a resistor. Now the reason why I have a resistor is so I can resist some of the current from this battery and the voltage, so that way it won't destroy the LED. So let's see what happens when we get rid of the resistor and replace it with a very high voltage source. Now this LED has a maximum voltage of 2.1 volts, and I'm going to be attaching 10 volts to it, so let's see what happens. See, it flashed. Well, it's not doing anything else now, but it burnt out. You see how it's black now? It doesn't work anymore. That is why we need resistors with our LEDs. So the maximum voltage of this LED is 2.1 volts. It draws 20 milliamps, and the battery source we're going to be using is 3.7 volts. So we are 1.5 volts over the limit. And in order to determine the correct resistor we need, we're going to be using Ohm's law, which is V equals I R. So that's voltage equals current times resistance. So the voltage we need to resist is 1.5 volts. We're going to do 1.5. That's going to be equal to the current, which is 20 milliamps. That's about 0.2 amps. 0.02 amps, I'm sorry. And we're going to multiply that by R. Now we just need to solve for R. So R is going to equal 1.5 divided by 0.02. And that's going to equal approximately 75 ohms. So we need a 75 ohm resistor attached to this LED, so that way we do not blow it out when we connect it to a 3.7 volt source. Now the closest resistor I can find to 75 ohms is 100 ohms, which is okay. We're going to be lighting up this red LED with this 3.7 volt battery source. So what we need to do is we simply take a resistor and we attach it to this LED. So the long side is positive, the short side is negative, and the negative side also has a little flat side on the LED. I don't know if you can see it. And you can attach this LED to, you can attach this resistor to any side of the LED. So I've attached the resistor to the positive side of the LED, the longer pin. I'm going to attach that to the battery source right here. Now, we have a black wire and a red wire. Most of the time when we do circuits, the red wire is going to be positive and the black wire is going to be the ground. And as you can see, it lights up. Oh, it just fell apart. So now it lights up and it doesn't burn out. Now we'll be lighting this blue LED. It has a different maximum voltage of 3.6 volts. The current draws the same at 20 milliamps. The power source this time is going to be 9.3 volts. And that means the voltage over the limit is 5.7 volts. Now we're going to use Ohm's law to find the correct resistance, which is V equals current times resistance. So now the voltage we're going to resist is 5.7 volts, which is going to equal 5.7 equals to 0.02 amps times the resistance. Now we got to solve for the resistance, which is going to be 5.7 divided by 0.02. That's going to give you 285 ohms. So we need a 285 ohm resistor, this minimum resistor, in order to light this blue LED up with this power source without burning out the LED. So I have 150 ohm resistors right here, and we need 285 ohm resistors. So what we can do is actually we can connect two resistors in series together to add the resistance together. So I'm going to be taking two of these resistors. I'm going to attach them in series, and I'm going to attach that to the LED. So now these resistors combined together have 300 ohms of resistance. So I'm going to connect the resistor to the positive side of the LED, which has a longer pin, and I'm going to connect that to a red wire to the power source, which is normally positive. Then I'm going to connect the negative, the ground, the black wire, to the LED. And as you can see, it lights it up. And that's how to find the correct resistance of an LED, or for the resistors. So this is the schematic we used. This here is the LED, this is the resistor, and this is the battery source. So you can put the resistor on either side of the LED, on the positive side or negative side, because the current in a series circuit is going to be all the same. So the resistor is going to resist this current right here. So think of the current as like cars in a freeway. This resistor slows down the current. So it's going to slow down the current here and here as well. And that's why the LED doesn't burn out. So the circuit right here makes a good dorm room decoration. You can put the little LED through your peephole, put a picture outside, and look, you got the Terminator. So now I put on the blue LED on as a decoration. And you get Mad Eye from Harry Potter. Although he looks a lot more like James May from Top Gear.